This project is all about position location, where we have 4 static nodes and 1 mobile node. From the static node we can measure the distance to the mobile node, and by using an algorithm we can determine the absolute location of the mobile node. This project is all about position location using trilateration. In mobile phone systems and satellites, there is an error associated with the distance measure from a static node, a mast, or a satellite. Here we see 4 nodes, and in the center a mobile node. The green lines represent the distance measure from the static nodes, and the bands, the 2 green bands, represent the high and low values associated with the error measure. So in this project we have 4 static nodes and 1 mobile node, and the goal is to determine the position of the mobile node using only distance information. And the distance information is associated with an error value, and the goal is to minimize the effect of these errors. The algorithm uses the sum of errors squared. Here are the main classes. The ones of interest, particular interest, are starred. MobSim is the thing which simulates the system. The monitor is the part of the algorithm that determines, that estimates the position, and the node has information relating to its size and position, and the static nodes have the R value, the measured distance associated with them. Control, myfile object, network thread, and normg have been used in earlier projects. This block of code, what we have here is the X is the mobile, X and Y are the mobile, capital X are the estimated locations, X, R and Y are the locations of the nodes, static nodes, and this particular block of code at the bottom measures the error measure between the estimated position and the R value, in other words the radius. The creep function, what this does it, you perturb the position of the mobile node and then calculate the error measure, and if the error measure has fallen or reduced, you then move to the new position. If this hasn't happened, then you disregard the move. I have loaded MobSim into NetBeans and set the error level to 2%. So I can run it now. The green lines are the distance measures from the node. The red is the estimated position, and the center of the green circle is the actual position. You can see it iterating. So the node moves and then the iteration takes place. So it's a sequence of iterations. I'll let this run for the for two cycles. This is a reset now. Okay, so I'll restart it. What I'll do now is change the error measure to something quite large, say 10, which is much larger than a real typical situation. And I'll switch on the error bounds. The error is a percentage of the distance, so you'll notice that as this gets closer to this node, that the absolute error size diminishes, and while at the same time this one is getting bigger. Now here it is coming back again. So this one will get bigger as it moves across to the right. Slowly. The error is normally much less than 10% in reality. Now I'll change the error to 1%. You can actually set the error to 0 if you wish as well. And I'll put the 2 green lines on. You can see now that the estimated position is closely matching the actual position, where the error measure, the error measure is quite small, 2% of the R value. Obviously the absolute value gets greater the further away that you move from the node. Okay, that's that then. I've set the error value to 5%, and I'm going to demonstrate that it is possible to terminate execution using the stop button, as this is a thread. This is one more run using the 5% error bound. Here you can see the R values changing as the errors are detected or introduced. The estimated value is quite good in the sense that it tends to stay within that green circle. I hope you found this video interesting.